More than 140 million households across sub-Saharan Africa still cook with wood fuel over an open fire. This style of cooking is an inefficient combustion process which leads to exposure to toxic smoke and excess fuel consumption. The poor fuel efficiency means families have to spend more money on fuel, travel farther to collect it, and cut down more forests in the process. The best path forward is to empower local manufacturing to produce durable, efficient cookstoves at a price that everyone can afford. The challenge is that most local manufacturing facilities don't have access to electricity and must utilize artisanal methods, which are not fast enough to meet the current demand for stoves. Burn Design Lab's solution is to customize existing hand-powered machinery to improve their production process. Cutting sheet metal was identified as the most inefficient process due to the time needed to mark out parts and then cut them with hand shears. The issue is that the thickness of sheet metal used in cookstove parts is too thin for standard production equipment, so it droops below the gauge that the machine cuts with. Also, the standard back gauge did not extend far enough to process all of the parts needed for the cookstove. To overcome this, Burn Design Lab has built a custom back gauge utilizing the principles of human-centered design. This gauge prevents parts from dropping, has a range of cut from 10 to 870 millimeters, and has as few moving parts as possible to lower the maintenance needs. This solution is crucial to local cookstove production, but can also be applied to any manufacturing facility in a limited resource area that has mid-level production volumes.